My name is Christine G, and I'm going to be going over this problem in Module 3, 9.1.35, or problem number 7. So we have a researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained if she wishes the estimate to be within 0.03 with 95% confidence if she uses a previous estimate of 0.36. So here we're going to look at, let me go ahead and get set up. Let me clear this one out. We're going to look at setting up the equation to figure out what the sample size should be. So n is the sample size, and then we have the sample proportion, or p hat, times the quantity of 1 minus p hat times the quantity of z, and then we have alpha over 2 over e. And then this is being squared. Okay, so let's take a look at this. First of all, we know that this E is the margin of error, and that's easy because we have that it is 0.03 for the estimate, the error estimate. So, and then we have, let's fill in what we do know, 1 minus, and then p hat, well, that would be the 0.36. And that is the sample proportion. Now we're going to look at, we need to obtain, so this z alpha over divided by 2. So we know that the confidence interval is 95%. So that means that there's 5% left over. And we'll write it as a decimal. So just moving the 5% over 2 decimal places to the left. And then we're dividing that by 2. So then we have, the score is 0.05 divided by 2, which is 0.025. Now we're going to use technology to figure out what that is. So let's go ahead, we'll look at StatCrunch. See, so I go in here and then StatCrunch, and then I'm going to go into Stat, and then Calculators, and then Normal. And then here I'm going to look at x being greater than or equal to, and then my value would be 0.025. And then I come up with 1 point, so x is the probability that x is greater than or equal to 1.959. So if I round this off to 3 decimal places, so 1.960 would be my value for the for z. So let me go ahead and get that up. So 1.960. And then from there, what we do is we use a calculator, and we can simplify it some before we jump into the calculator. So 0.36, 1 minus 0.36, that's 0.64. And then I would do this, 1.960 divided by 0.03. And then I come up with 65.333 repeating. And then I multiply that by 0.64, and I'm leaving this in my calculator so that I do get something that's very close to what it should be. So, oh, I forgot. Okay, so here, first thing I'm going to do is 1.960 divided by 0.03. When I get that amount, then I have to square it. So I get like 65.333 repeating, and then I square that, and I get around 900, let me see, no, the 4,268. And I'm leaving this in my calculator. But just to give you an estimate, and then multiply these numbers out, and then I come up with 983.45. And then what I would do is, because we can't have a sample that's 0.45, so we just round up. So it would be 984. And that's what we got here. All right, so now part B, she does not use any prior estimates. So let's go ahead, I'm going to clear this out. And so that formula to get that sample is n equals 0.25 times the A alpha over 2. And then we have the margin of error divided by the margin of error, and then that's being squared. So we're going to do the same kind of stuff here where we just substitute in for the margin of error and z-score. So this one is 1.96, and then the margin of error is 0.03. And then we're squaring that. And then I'm coming up, when I do this, I do 1.96 divided by 0.03. And then from there, I just square it. So 1.96 divided by 0.03 is 65.33 repeating. And then I multiply that. Then I go ahead and square that, 4,268.44. Oops, 68.44, and then multiply that by 0.25, and then I'm coming up with 1067.11, and of course round up to the nearest integer, so 1068, and that would be the answer. So I hope this makes sense. Thanks so much for watching, and feel free to reach out with any questions you have. Have a good one.